Okay, bro, you can share your screen quickly. Share. Give me the remote control. Okay. Can I open the paint? Okay. So, bro, I have created a timer interrupt. Okay. Every 1 second, it will create a timer interrupt. Okay. Like this. Don't. So every 1 second, it will create a timer interrupt. Okay, so when the timer interrupt happens inside the ISR interrupt service routine, I am enabling a pulse. Okay, like a pulse high. Okay, and then I start writing the DAC bit. DAC value. Okay. So after writing that value, I am lowering that GPIO. Okay. I am using PB6 as PB6. Okay. After 1 second, again timer interrupt happens. The GPIO goes high. Okay. And then we start writing the value on the DAC. After that, the GPIO goes low. Okay. So we need to find out this time. Okay. So this is the time to write one data point. So this is a time to write one data point. So this is the minimum time we need to find out. Okay. So I have also mentioned this as T1 in my notes when I sent you two pictures. Okay. So we need to find out this time. Okay. With the help of oscilloscope. So we need to find out this times. This is the time for one data point, and with the help of this time we can decide, like we can write if we are making a sine wave, we can write different data points like increasing voltage,
Yeah, I
now
understand. So
decreasing.
like a sine wave we can
Yeah,
generate.
yeah, like
Wait,
a
but
sine wave.
did you see the timer thing I sent you? Do those pictures not help?
No, that is not. uh, so basically the picture, the thing we did was not this T1. Okay. Basically that was the time from so basically when timer interrupt happens. Okay. So the CPU does not immediately goes to ISR. Before going to ISR, it saves the current context. Okay. For example, if it is doing some calculation, it is doing some for loop,
Right.
and the interrupt happens, it needs to save the current progress into some registers. Okay.
I understand.
And then,
Yeah.
yeah, and then it goes to serve the ISR. So that time, to save the context, to save the current progress, that is different time, and this is different time. We need to add both. We need to combine these times and to find out what minimum time does it take for one sample,
So how do
because
I do
we are
that?
writing, yeah, we are writing each sample inside the ISR. So we need to find the so let's say this is the normal code execution. Okay. So this is the time uh, before jumping to ISR, and after ISR, we write one data point as well, and after writing the data point, it takes some time to restore that progress. okay, because it has saved that progress. So it restores the progress and goes back to normal routine here again. Okay, so this is the time you need to find out T1. Okay, and this time from here to here. So this time was from the A3.
So that T1 time, is that the length of the interrupt or is that the length of like this saving the progress before
No,
executing?
no, A3 is saving the progress. Okay,
Okay.
and you need to find out the T1. Okay, so what you will do, you will hook up the oscilloscope to pin PB6. Okay, and then you need to, so you will get pulse like this. Okay, so it will go on every 1 second like this. So you need to make this pulse very large. You need to enlarge the pulse, and with the help of two cursors you need to find out the pulse width. Okay, so you need to find out the time between these two edges, so that is the time. In this time, this time might be in milliseconds or maybe microseconds. Okay.
Okay. I don't need a screen capture or anything, right? Like I just need to know.
Yeah, take the screen capture as well. Just take the photo from your mobile. You don't need to do
Okay,
the
but it
actual
doesn't have to
capture.
go in the report or anything, right? Like I
No,
don't.
no, no, no. Yeah, it will go to report as well. Okay. If you open the P1 document, I
Okay.
can quickly show you.
No, no, just so I know. Okay, all right.
Yeah, it will go to
So I have
one
a
more thing
question. I
before
have
I
a
go.
question.
Yeah,
So how do I test that timer interrupt? Like what do I do?
you need to run the code.
So I run this. Is there a
Yeah,
set break? Is there like a set breakpoint?
yeah. Let me quickly give you this. Okay.
Give me one
So
second, please.
for
Give me one
example,
second.
I am
Give me
so
one
I
second.
am writing. So I am right.
Give me one second, please. So that time that it takes for the actual thing,
Yeah,
is that in the time that it takes, is that in like is that a value in the code that will change?
in the code will change.
So like the T1 time.
Yeah,
Say it's like 100 milliseconds or something.
yeah, yeah.
Is that a value in the code, like a variable or a constant in the code?
1 second. Yeah, as you can see, I am running the CPU clock at 80 megahertz right now. Okay. So with the help of prescaler and ARR, I am creating a timer interrupt long enough so it can at least give out one data point. Okay.
Okay.
And the data point is like applied here. Okay.
So what
So
value are
as
you changing for
okay,
T1?
yeah, I am writing only one value. Okay. So if you see, this is the DAC write function. So I am writing 2048. So that means that is half of 3.3 volt. So that will be 1.65,
Yeah, but like
1.65 volt.
the actual time itself, which value do you change?
That is not in my control. Okay. You need to find out that time.
Yeah, yeah, but then where do you store that in the code?
Okay. When I will find out that time, okay, based on 100 hertz, based on 100 hertz waveform, I will test how many data points can I set in the code in an array. Okay. Um,
The
then
reason
I
why
will,
I'm
yeah,
asking because this is like the frequency measurement code.
yeah,
If there's a set variable in here with that already, then I don't have to test. Like if you were saving the time somewhere.
yeah. Oh, bro, you cannot save that time because all the things will be saved in the RAM, and when the microcontroller lose its power, it will be finished. So you just take a photo from your mobile. It's not big deal. While the other things, I will save them in like,
No, I'm saying I know, but I'm saying like, is that the T1 time, was that already something that was measured in A7?
no, 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 not here. That was a different thing.
No, this is not A3, this is A7.
Yeah, this is A7. Yeah,
Yeah. So I'm saying like if you took that T1 time with the length of the interrupt cycle, right? Oh, I guess it's gonna
yeah,
be different for each program, huh?
yeah.
Oh, okay, okay.
Yeah. This is different
That's what
for
I was
each.
asking basically. Okay.
Yeah.
All right.
And so let me quickly set it up. UEIF. Instead, I can also GPI. I hope you will see the green LED toggling.
Yeah, it's blinking.
Everyone's,
It's blinking, yeah.
yeah. Okay. So this timer interrupt is being generated every 1 second. Okay. See the output on the DAC IC. It should be 1.6 or 7.6.
Yeah, 1.6.
Yeah. Okay. So this is the interrupt being happen right now. Okay. So I am enabling the, and so when the interrupt starts, I am making the PB6 high, making.
So I have a question, like how do I check this on the oscilloscope?
So you will attach the oscilloscope on PB6 and ground.
So
Okay.
that
So it will,
PB6 is the pin 8, right?
yeah, making PB6 low. I, I don't know what is the pin number 8, but you see the PB6 from the pin out diagram. Okay, got it?
Oh, wait. Okay, because right now, wait, the output pin isn't connected to anything.
Yeah, yeah. No, you don't worry about the output pin. Okay, you need to find out the time because
Oh,
the
directly
uh,
from PB6 is what you're saying.
yeah, directly from PB6, not from the output. Output is being controlled right now. Okay, so DAC value. So this DAC write function, it is taking the value. Okay, and it is writing that value to the SPI, which is the DAC IC. Okay,
Understood.
so since this is working right now, so it will take the amount of time it needs here. Okay, and after finishing this function, we will make the GPIU low. So it will give us a time space at which this 2048 value is being done on the DSC.
Okay. So I connect the two. Okay, but that value is going to change depending on what we measure.
No, if you change any value, like if you write 000 from here, it will take similar time because the DAC IC is 12-bit long. Okay, so anything you write here, it will take 12 bits time. Okay, so it's not like if you write one, it will take less time. If you write 4,000, it will take more time. No, it will take only one time because it needs all the 12 bits to know what the microcontroller wants. Okay, so microcontroller needs to send all the 12 bits to the DAC, so it will take complete time. Even if you write 0 here, even if you write 5 here, or 10,000,
Oh,
not 10,000, the maximum value is, since it's 12 volts, so maximum value is 0 to
okay, but
4095. Yeah.
so where are you saying how many data points you set or however long the interrupt period is? Where are you saving that? Like, okay,
Okay.
say I give you the time. What do you
Yeah.
change?
Okay, so when you give me the code, I will create a table like this. Okay. For example, I like the table sign table. Okay, and I have calculated, I need around 400 samples. Okay, so I will create that sample table with the help of MATLAB. MATLAB will give me values like 2048 starting from the middle, and then it will go to 1. Okay, like it go to 233. Okay, eh, something like this. And then with the help of this sign table, I will create a index or a counter. So I will write like this. So I will write DAC output sign table and the counter plus plus. Okay, so each time the interrupt happens, I will speed up the interrupt. So right now I have write the interrupt long enough so it can, you can easily see the one data point. Okay, but when you find out the time, okay, and I will add the ISR, context saving time, so I will join them, and based on that time I will make the decision how much data points we need. For example, we need 400 data points or 1000 data points. I will make the table of that 1000 data points. Okay, and then I will speed up the interrupt by reducing these values. Okay, and then what the timer will do, timer will create the interrupt, and on each interrupt I will write each data point to DACIC. Okay, and then DACIC will generate the voltage according to the each value.
I
Okay.
see. I see.
Yeah.
Okay. Okay.
Yeah,
So,
something like this. So
oh,
let
you
me
might want to
just,
comment out that portion from the top.
uh,
Yeah. Okay. So okay. So basically, I need to connect to PB6 because that's like the high and low that you're setting for the timer.
yeah.
Um,
Oh, okay. I'm also available here, like for the next 12 to 14 hours. Okay. So if you are in the lab, if you don't understand anything, just write me the message. I will quickly reply you. Okay. Even
okay.
if you get the wrong value, just send me the picture of the
Yeah,
oscilloscope
but
that
I
you
just
are
want to
getting
know.
this.
Okay, but basically, so I connected to PB6 and to ground. I
Yeah.
run the
But
code,
yeah,
and
yeah.
it'll generate some sort of waveform that I zoom in.
Yeah, it will generate the waveform, but you need to zoom in that waveform. Okay, and you need to find out the time between the two edges. How you can measure the time? You can use cursors. You know how to
I know
use
how to use
cursors on the.
cursors. Yeah, yeah, yeah.
Okay, just take two cursors, place one cursor on the rising edge, place one cursor on the falling edge, and note that time out, and take that screenshot because you need to write that in the report as well.
Okay.
Yeah.
I have a
Okay.
question.
Yeah, yeah, sure, sure. You can ask. One more thing, I
Um,
need to speed up the SPI also.
all the pulses are going to be same length, right? Like there's not a
Oh,
specific pulse I need to measure.
voltage? No, no, you don't need to measure the voltage because right now we are not creating any
No, but I'm
waveform.
saying like because there's going to be multiple pulses, right?
No, no, no. Yeah, there will be multiple pulses. So you just take only one of them. All of them are same.
All of them are same. Okay,
Yeah.
got it. Okay, all right.
Okay. Before you go 0, 0, so maximum value is 80 megahertz. If you divide it
So this is not
by,
like I have to set.
No, no, no. You don't need to do anything on the code.
Okay, okay.
Let me write. Yeah,
Yeah. And if I'm able to
one.
message you, I will. Hopefully I'll get
Okay,
access within, I would say about 7, 8 hours from now.
okay. Just quickly wait
Whenever
here
you're
and
ready.
let me speed up the I2C SPI clock. So because the maximum speed this IC can take, that is the 20 megahertz. Okay, so I am checking it. So dividing it by 4,
Can I
0
disconnect the
plus.
keypad or do I need that connected?
No, no, no. Keep it connected. Otherwise, you will need to make the connections every time.
Okay, okay.
Yeah. Okay. So I am speeding up the I2C right now. So let me check if it works again. Let me write the value of 300, 3000. 3000. Okay, try to read the voltage now. It should be 2.3 or 2.4 volt.
Yeah, 2.4.
Yeah, okay. Okay, so everything is set up right now. So you just go to the lab and test on the oscilloscope and find out the pulses.
Sounds good.
Okay,
Okay. Yeah.
okay. You have any questions? Let me
No.
know.
Okay.
Okay,
All
okay,
right.
bro. I'll see.
Yeah, see.